1. My name is Apostolos.
And my name is Travis.
In our project, we explored the prediction of the popularity of a YouTube video using its metadata.
For our presentation today, we'll talk about how we collected the data for our research and the 2 data science papers we researched and reproduced.
YouTube has grown in its own industry, allowing many creators to make their livelihood using the platform, which means predicting popularity of videos could be of value to them as it relates to monthly and yearly revenue.
For this report, we elected to write our own code to mine our own dataset using the YouTube Data API. To do so, we queried the API to get a list of new videos posted to YouTube. Then we got statistics about those videos such as views, likes, channel subs, etc. We then measured those stats every 30 minutes for 5 hours for 10 time steps for each video. This process was repeated 3 times for a total of 150 videos and 1,500 data points. Then we cleaned the dataset, removing a few videos that had comments disabled or were taken down during our data collection window.
The first paper analyzed forecast audience increase on YouTube. The author used multiple linear regression to determine what variables were of most importance for a channel's popularity. The dependent variable used was subscriber count, and the independent variables used were users followed by the uploader, the unique number of videos that the uploader viewed, the total videos that the uploader uploaded, video views and video likes of the video being examined. The author used a time series data set to predict change of popularity over time. For our own methodology, we chose video likes as our independent variable, and dependent variables as video views, video comments, channel subscribers, channel total views, and channel videos. We used our own time series data set for an analysis, and then we did a random train and test data split of 80% and 20%. Subsequently, we trained our model using a time series data approach from earlier time steps to predict the last time step. The training accuracy of the first model was 68.7%. The testing accuracy fell down to 65%, and when we did a time step approach, the accuracy reached up to 72%.
The second paper we looked at calculated a popularity parameter metric for each video defined as a ratio of likes to views. They then classified each video as either high, medium, or low popularity based on the video's popularity parameter. They then trained and tested 4 machine learning classification algorithms to predict the popularity of the videos. Because no code was provided in this paper, we had to implement their methods with our own code, and the accuracy we got is on the table to the left. The authors used 3 accuracy metrics to gauge model quality: model prediction accuracy, tenfold cross-validation accuracy, and the area under the receiver operating characteristic curve. For our own analysis, we elected to use our time series dataset to train our machine learning models using earlier time steps to predict later time steps. We used the same classification schema as the researchers, so we calculated the popularity parameter for each video and classified them as high, medium, and low popularity. Then we trained and tested the same 4 machine learning models, and the graph on the right shows the changes in the accuracies over time. Our models improved as the time steps went on, which makes sense given they were given more and more training data. The notable exception is the cross-validation accuracy, which we believe is due to the fact that the cross-validation takes random subsamples of the dataset, and we were using a time series dataset.
To conclude, popularity data for YouTube can translate to real income for content creators. We collected our own time series dataset by querying YouTube's data API using our own Python software. We performed multiple linear regression using our own dataset over 9 time steps. We also created 4 machine learning classification models over 9 time steps using our own software. Due to a limited dataset, our novel results performed slightly below the original analysis. However, we believe that given more time to acquire a more robust time series dataset, we could have likely outperformed the models presented in the research papers.
Thanks for listening.